Alright, hi everyone. So for today's lesson is the second lesson for our topic differentiation. So the learning outcome for today is pretty easy. We are going to know how to find and how to calculate the derivative of natural base and also natural logarithm. And also you will need to apply it together with what you have learned previously with an expression with constant multiples, sum difference, and composite, or even the quotient rule and the product rule that you have learned previously. Okay, so we'll be doing this video in like two sections. So the first one, we talk about the exponential function first, meaning the natural base e. Then after the derivation part, then we are going to look at some of the questions. Then after that, we move on to the proving part for your natural logarithm, then also some questions. Okay, so let us start with the introduction for derivative for exponential function. So this is how the derivative come from. But as what I say, before this, there's none of the past year question actually ask you to derive the formula. So this is like for your knowledge, for you to understand how the formula come from. Okay, so let's try to do this. So this is actually a graph of fx or y equals to e to the power of x. Okay, so if you can recall, right, we when we learn differentiation, I mentioned that when we talk about dy dx, is actually for example, for this curve, I want to find out what is the gradient on this part. So it will be like pretty difficult for me to find because I do not have these 2 points actually on this curve, because this is like a tangent, so only 1 point can be on the curve itself. So that's why what I'll try to do is, instead of like finding the gradient for the tangent, then I'll try to find out the gradient for the other line. So for example, from this one, then after that I'll try to move it nearer and nearer. So when the difference between these 2 points is getting nearer to 0, then we assume that that's the gradient that we want. So we are going to use this approach also to help us to actually find out what is the derivative for fx equals to ex. Okay, so let us try to do like this. So let us start with dy dx. Yeah, just to let you know, this might be not the not the exact mathematical way to prove it, because you didn't learn like first principle in your syllabus. So that's why this is like a rough idea for you only. Okay, so you can try to imagine. So let's say just now we said that we are actually finding the gradient between these two lines. Then after that, we try to move it nearer and nearer to the point that we want to find out the gradient. Then the answer itself will be the gradient for my tangent. Okay, so what you can imagine is, let's say I try to put these 2 points. So if this point is actually my x, so what will be my y? Because I know that this graph is drawing for y equals to ex, right? So that's why my y will be natural base than x. Okay, then after that, I move on to second one. So when we move on to second one, actually what we try to do is, later we want to move this point then nearer and nearer to x, so that the small change in x will actually approaches to 0. So this part is actually x plus small change in x. So meaning if this is 5, then this is maybe roughly 5.5 and so on. Then later we are trying to move it nearer and nearer. So if that is x plus small change in x, then what is my y? Then my y will be e to the power of x plus small change in x, correct? Okay, so now let's try to put into our equation here. So we are just using the formula for our gradient. So this is the concept of limit. So later what we try to do is, we want to make our small change in x approaches to 0. So let us write down the gradient that we have here. So this is like your x2 and y2, and this is like your x1 and y1. Okay, So let's try to substitute. Okay, so the formula for gradient. So y2 minus y1, which is x plus small change in x and minus ex, then over your denominator will be x plus small change in x and then minus x. Okay, so let us try to simplify that. Limit small change of x approaches to 0. So can we try to do factorization? So power of x, then after that, what do you have inside? So you need to get back to this form, right? So that's why base and small change of x. Because this is multiply, so that's why you plus together their index, so you can get back the exact form before that. So ex, then you're left with 1. Okay, then over, so you simplify them, then you will get small change in x only. All right, so now let us try to continue to do that. So we will be using this table. Okay, so we will be solving it one by one by using like limit, then small change of x approaches to 0. We try to take out the ex first because this is non related to what we try to do, which is make our small change in x approaches to 0. Then we try to write another one, which is small change in x minus 1 over small change of x. Okay, so they are the same thing. I'm just trying to rearrange it. So we'll be looking at this part because this is the part that we are trying to make our small change in x approaches to 0. Okay, so let us try to find out some of the small value of, so I already write down this is like the exact form here. Okay, so let us try to substitute some of the number that is like very small and near to 0. Okay, let's say, let us just try to do 0.1 and then sorry 0.1, then after that 0.01, 0.001, then 0.0001. So you can see all this value is approaching to 0, right? So it's the same thing. Let us try to just use our calculator to put in the number. So the first one, I have to the power of 0.1 minus 1 and then over 0.1. So this one, I'll get a number that is 1.0517. Okay, so maybe write more decimal place because you want to do comparison. Okay, so the same thing. Let us go to the second one, which you have your 0.1 to be 0.01. So what you will get? So you will get 1.005017. Okay, so move on to the next one. Same thing. Try to change your 001 01 into 001. Okay, so you will have, like you can see the number becomes smaller and smaller. So 1.000500. Okay, so you can continue to find out the next one, and I think you will get the number of 1.0000050. Okay, so when what you can see is when all this range, right, which is your small change of x, is actually getting nearer and nearer to 0, what happened to this? This will actually nearer and nearer to what? So you see from 1.05, then go to 1.005, then 1.00005, then it becomes smaller and smaller, but it's nearer and nearer to 1. So you can check it out, right, with other like very small number, right? So yeah, I'm just trying to put in like 1, 2, 3, 4. Okay, 6, 0. So I put in another 4, 3, 4. Yeah, so you can see the number actually approaching to 1. So if you try it out, right, you will never get an answer that's smaller than 1 already. Okay, so that's why when we have the small change of x is approaching to 0, I'm sorry, my typo here, but I'll try to change it in your handout, don't worry. Okay, so as the small change of x approaching to 0, what do you realize? You realize that to the power of small change of x minus 1 over small change of x actually approaching to 1. Okay, so when we look back our function here, right, so you imagine if this part you are getting a 1, that meaning what do you left? You actually left with x multiplied by 1, correct? So what do you get? You get ex. So this is like your dy dx. Okay, so yeah, because we already finished the limit when we try to approach the small change of x to 0, so that's why this part is become 1 already, and you solve this already, right? So ex, there's none of the term related to small change of x anymore, so that's why dy dx will be equals to ex multiplied by 1, so which we get our first derivative dy dx equals to ex. Okay, so the first thing is when we have y equal to e to the power of x, the derivative will be equals to e to the power of x. Okay, so that's the first part for our derivative for e to the power of x. So there is no change when you try to differentiate it. Okay. Okay, so now we're looking into the second part. So the idea is that you can imagine that not every natural base have an indices of x. So you need to imagine if let's say you have like x squared, you have 2x plus 3, then how are you going to solve that? Okay, so from this derivative, we are going to derive another one, which is the derivative of e to the power of fx. Okay, so how are we going to do that? So it's like quite an easy one. We are going to use substitution to help us to derive that. Okay, so you have a function of y equals to e to the power of ex. So, sorry, e to the power of function of x. So what we try to do is instead of writing it into function f of x, so we try to let our y equals to e to the power of u. Okay, so what is actually your u? Your u is basically your fx, right? Okay, so now we try to differentiate it. Then after that, we are going to use chain rule to combine them. Okay, so dy du, right? This is in terms of variable u. So what do you get when you do dy du? So just now we learned that when y equals to e to the power of x, dy dx is ex, correct? So that's why when I do differentiation for e to the power of u, I'll get e to the power of u as well. Okay? So what do I when I differentiate when I u equals to function f of x, so when I actually differentiate with respect to x, so meaning now this one will be du dx. Okay, so when I do my differentiation, I don't have my function here, right? But I know that I'm going to differentiate it, so that's why I just write it in this way. Okay, so we are going to use the chain rule. So since we want to find dy dx, right? So dy dx will be equals to dy over du multiplied with du over dx. So now we can substitute what we have gotten here. So dy du is e to the power of u. Then what is du dx? Du dx is f prime x. So we have f prime x. Okay. Okay, so now let us try to, yeah, so you can see there's a term of u here, and we do not want the differentiation of dy dx to contain a u here. So that's why we try to change it back where your u is actually function of x. So e fx multiply by f prime x. So let us try to rearrange it. Then you will get f prime x then e f x. Okay, so what is this mean? So it means that when you have anything that is not x only, meaning for example you have 2x, then what you need to do, you need to differentiate what you have on the indices, then after that bring it down. Okay, so that's it. Yeah, like the differentiation form for fx, then after that the indices will stay the same. So for example, if let's say you have e2x, then you differentiate 2x so that you get 2 in front, so your answer will be 2x. 2e, 2x like that. Okay, so you can write down your second formula here, which is when your y is equal to e to the power of fx, then you can always write it dy dx will be equal to f prime x and then e power of fx. Okay, so now we'll try to look at like few examples here before we move on to the natural logarithm. Okay, so let's try to look at few examples. So we'll start with a very easy one, e to the power of x. So maybe we just try to let our y equals to ex. Okay, so y equals to e to the power of x. So just now we said that when you have ex, so after you differentiate, you should be getting the exactly same thing. Okay, so move on to b. So when y equals to, when y equals to e to the power of 2x, okay, so this is like e to the power of fx. So what do you need to do? You need to differentiate your indices, then after that write it in front of your e. So 2x differentiate, you get 2. Then after that e, then indices doesn't change. Okay, so please remember, do not do minus 1 over there. Okay, so same thing. So y equals to, so let us try to change this in indices. So ex to the power of 1 over 2. So let us try to combine. So 1 over 2x. Then now you can do the exactly same thing. Dy dx will be actually equals to 1 over 2 e to the power of 1 over 2x. Okay, as simple as that. Okay, let us try to move on to the next one, e to the power of x minus 4x squared. So this is same thing, e to the power of fx as well. So you can just y equals to e to the power of 4 minus 4x squared. So next, you just differentiate what you have for the indices. Okay, so after you differentiate, so x become 1, then 4x squared will become 8x. Alright, then indices, you just write it. So make sure that you are not making like your e is like the base for 1 over 8x only. So write it properly, like all the spaces and which one is bigger, which one is smaller. Okay, then after that, let's move on to e. Okay, so for E, you have two ways to do that. So when you look at this one, right, you can actually decide whether you want to expand it first or you just treat it as composite. Okay, so both you can get the answer is the same with the normal function, which you even you don't have natural base, then you have, for example, like 3x plus 5, then whole thing to the power of 2. So you can decide yourself whether you want to expand it first, then after that differentiate it as usual, or you actually want to treat it as like fx to the power of 2. So it depends on you. So I'm going to show 2, then after that you can, as your reference. Okay, so 2ex plus 3e negative x to square. Okay, so let us try to see the method 1. So method 1 meaning you're just doing expansion. So y will be equals to 4e 2x. Then after that you will have plus 6, so you get 12. And then after that e to the power of x, then e to the power of negative x. So when you plus them together, you get e to the power of 0. So e to the power of 0 will actually give you 1. So that's why you left with 12. Okay, then plus 9 e negative 2x. Okay, so if you are confused with this, then you can try it to do it like much more step by step lah. Okay, so after you get this, then you can start your differentiation, like treat it as usual. So 2x, so that's why differentiate, you get 2. So you have 8 in front, e 2x. Okay, plus 12 is your constant, so nothing already. So negative 2x, differentiate, you get negative 2. So multiply it in front, you will be able to get negative 18e to the power of negative 2x. Okay, so this is like method 1. So method 2, if you do not want to expand it, then what you can try to do, treat it as composite. So you straight away do your dy dx. So power, bring it in front, right? So you have 2, then your function f, you will be copying it exactly the same. Power minus 1 will give you 1. Then after that, differentiate what is inside. So 2ex, after differentiate, you get exactly the same thing. For this part, you get negative 1, so it will make it become negative 3e negative x. Okay, so now you can try to expand it. So 2, then expand the term behind it first. So 2e 2x, then after that, what you can realize is plus, yeah, so minus and plus, so it will give you 0. So then minus 9e negative 2x. Okay, then you can try to expand it because this is the constant. Like this is not like 2 to the power 2 to the power of 1. So you can just expand, like multiply it. So 4e 2x minus 18e to the power of negative 2x. Okay, so you see Do I do something wrong? I'm sorry, 2 times 2, so this is 4. Okay, so that's why it's 8. Alright, so that's why you get the exact same answer as method 1. Okay, let's move on to the next one. Okay, F, so this equation might look a bit complicated, but actually what you need to do is you need to use your previous knowledge that you have learned in what is that called, exponential and logarithm, to help you to actually simplify this. Then everything will become much more easier. Okay, so what we can try to do is we try to separate, like split them into 3 different fractions. Then after that we do simplification. So e to the power of x over e to the power of 3x plus 1, and then minus e 2x minus 1 divided by e 3x plus 1 plus 2 over e 3x plus 1. Okay, so now we can start to do our simplification. So I'll get e negative 2x minus 1. Okay, minus e, then same thing, negative x minus 1, then minus 2, plus, so you have 2 over there, so 2 negative, e negative 3x minus 1. Okay, so now you have this term already, then you can treat it like usual, that you can straight away do your differentiation. So the idea is by doing this, then we do not need to deal with u over v. Then it might look like much more complicated, but later we are going to look at the example which you can simplify like this. Okay, so same thing, you will get negative 2, then e negative 2x minus 1, so negative 1, so plus e negative x minus 2, so negative 6e negative 3x minus 1. Okay, so move on to G. Okay, so G, y equals to x, then e to the power of negative 5x. So what you can realize here is I can't simplify it anymore. And this is basically like one function and another function, which we can write it in the way of y equals to uv. Okay, so that's why for this one, no choice, we must do product rule. Okay, so if the x here is like a constant, so meaning if you are having like 5e negative 5x, then the 5 itself is not like a function of x, right? So you do not need to do this. So you can just straight away negative 5, then you get negative 25. But this one is x in front, so that's why we must treat it as uv. Okay, so just let y equals to uv. So I have u equals to x, and then v equals to e to the power of negative 5x. So du dx is 1. Okay, then next one, dv dx is negative 5e negative 5x. So now we can substitute. So dy dx will be equals to, what is that? So u dv dx, then after that plus v du dx. So you just substitute whatever that you have here. So u is x, then negative 5e negative 5x as power, plus e negative 5x du dx is 1. Okay, so let us just combine them together, or you can try to do some what is that called, some simplification, factorization. So both of the term has negative 5 e to the power of negative 5x. So what do you left inside? You left with negative 5x, and after that plus 1. Okay, so this will be your answer. If you want it to be nicer, then you change it to 1 minus 5x lah. Yeah, but that's totally fine. Okay, so let's move on to the next one. Okay, so y is equal to e to the power of 3x over x squared. So from what you can realize here, this is also something that you can't actually simplify. So depends on you. So either you go to the idea that you want to change it to x minus 2, then after that e to the power of 3x, then you try to solve it with y equals to uv, or you just treat it like this, then you solve by y equals to u over v. Okay, So since we use product rule just now already, then we try to use the quotient rule lah. So y equals to u over v. So u is equal to e3x and v will be equals to x squared. So when you differentiate it, then you will be getting 3e3x dv dx is 2x. Okay, then we can continue. Dy dx will be equals to v. Okay, let me just write down first. V du dx minus u dv dx, then divide by v squared. Okay, so now you can substitute everything here. So x squared 3e3x minus e3x 2x. Okay, so same thing, you can try to do some factorization later. So v squared is x squared. Okay, so now let us try to simplify it. So you can see you have e to the power of 3x and also x in common. So x e 3x. So what do you left inside here? So 1x is already taken out, so you're left with 3x, then minus 2. Okay, then divide by x to the power of 4. So since x 4, then x, then you can try to cancel it out, the x up there. So you're left with e 3x, then 3x minus 2 and x cubed. Okay, all right, so let's try to look at one more questions, then we'll move on to the second part of the lesson. Okay, so this is like a application question, so we are just going to do a very quick one here. Okay, so the given the equation of the curve, so we need to find the exact value of the x coordinate at the stationary point and find out the nature of the stationary point. Okay, so for us to find out stationary point, then you should remember that you need to do dy dx equals to 0, right? So that's why let's start with the derivative first. So y equals to e to the power of 2x minus 9ex plus 7x. Okay, so I have dy dx. It will actually give me 2ex and then minus 9ex, 2e, 2x, sorry, and then minus 9ex and then plus 7. Okay, so after I have get this, then I can continue to find the stationary point. Then I have dy dx equals to 0, correct? Okay, so meaning that I need to solve that. So 2e 2x minus 9e to the power of x plus 7 equals to 0. So this is what you have learned previously, right? So how do we actually solve this? So you can always change this into ex, then bracket in square. So that's why we just let y equals to e to the power of x. Okay, so to make it easier. So 2, maybe we just rewrite this first. E x squared minus 9ex plus 7 equals to 0. So you have 2y squared minus 9y plus 7 equals to 0. Okay, so now you can continue to solve it. So you will actually get 2y minus 7 and also y minus 1. So you have y equals to 7 over 2 and 1. Okay, so we need to find out the value. So since y is ex, right? So that's why I have ex equals to 7 over 2. Then the other one is ex equals to 1. Okay, so how do you solve this? You need to change it into natural log, right? So change it into log. So x will actually equals to natural log 7 over 2. Okay, yeah, you still remember? So you need to log base e, then 7 over 2 equals to x. So log base e is basically natural log lah. Okay, so by using, you can just leave your answer there first, then after that we solve it. So e to the power of x, so your x, I think this one is easy, right? E to the power of 0 give you 1. Okay, so now you have these two answers, then let us try to find out the maximum point and the minimum point here. Okay, yeah, because they want the answer in exact value, so that's why we are not going to solve this out lah. exact value meaning like if your answer with square root, then you must write down square root. So meaning that you should get an exact value instead of like changing it into a rounded value. Okay, so how do we find out the nature, determine the nature? So meaning that we need to get whether it's maximum or minimum. So with that, we need our second derivative. So just now we have our dy dx already. Now d square y dx square. Okay, so differentiate one more time. So our equation was 2e2x. So you will get 4e2x. Okay, then after that, the next one, it will be negative 9ex. So you get exact same thing, negative 9ex. So plus 7, which gives you 0, right? So with this, then you will need to continue to do that. So when x equals to natural log 7 over 2 d square y dx square will be equals to e for e 2 natural log 7 over 2 minus 9e natural log 7 over 2. Okay, so don't worry, you just try to check everything out in your calculator. Yeah, so just put in everything for e and then 2 natural log 7 over 2. Okay, close it. Then after that, minus 9. Same thing, e log natural log 7 over 2. Okay, so when you solve it, then you get a positive value, which is 35 over 2. So 35 over 2 is greater than 0. Okay, so if you can recall, greater than 0 meaning it's a minimum point, right? So the same thing, move on to the next one when x equals to 0. So second derivative will be equals to 4e 2 0 and then minus 9e0. So e0 will give you 1. So 4 minus 9, negative 5, smaller than 0. Okay, so when your second derivative is smaller than 0, meaning that it will be a maximum point. Okay, so if you want to rewrite, then you can rewrite the whole thing again like x equals to this one is a minimum point, then x equals to 0 is the maximum point. Okay, all right, so let's move on to the last section of the lesson. Okay, so now we are going to look at the derivative for natural logarithmic function. So we are going to use the result that we have learned for natural base for us to derive this one. So it's going to be a shorter one compared to the previous one. Okay, so you have a function of y equals to natural log of x. So let us try to change this into exponential form. Then what do you have? Then you will have x equals to e to the power of y, right? Because natural log is log to the base of e. So e to the power of y give you x. Okay, so after you have get this, then now let us try to do differentiation. So when we differentiate x with respect to y, then it's dx dy, right? Then just now we learned that when you differentiate e to the power of x, then you will get back the exactly same thing. So that's why when you try to differentiate this, then you get ey as well. Okay, but what is the interesting thing that you can realize here? What is ey? Ey is basically x, correct? So we try to change it back. So dx dy is actually equals to x as well. So now, but then what we want to find, we actually want to find dy dx, right? Because we still, the idea for the derivation is to find out what is the formula for us to differentiate y. So what do you get? So if dx dy is x, so dy dx is 1 over x. Okay, so as simple as get that, you get the third formula for this lesson, which is when y equals to natural log of x, then what do you have? You will have dy dx equal to 1 over x. Okay, so now the next part is the same thing like the exponential just now. We cannot expect that all our function to have 1 over x. we can have all the other value or even a function for the denominator part, for the x part. So that's why we are going to derive the other one for the natural log for fx as well. So we are going to use the exactly same thing like how we do the derivative of e to the power of fx just now. Okay, so let y equals to natural log u, where your u is fx. Okay, so let us try to differentiate it. So dy du. So just now we already know that natural log u, when you try to differentiate, then what do you get? So if x then become 1 over x, so u become 1 over u, right? Okay, so the next thing is the same. So du dx is f prime x. Okay, so now same thing. Let's try to use the chain rule. So dy dx will be equals to dy over du multiplied by du over dx. So substitution, 1 over u multiplied f prime x. So same thing, what is what is u? So your u is fx, right? So 1 over fx multiplied by f prime x. So let's combine that, then you'll get f prime x over fx. Okay, so meaning that you are going to differentiate and write it as the numerator of the fraction. Then after that, the function will become the denominator of the fraction. Okay, so same thing. We are going to look at we are going to look at one example before we end the lesson. So let us just write down this first. Sorry, I have forgotten. So y equals to natural log fx. So your dy dx will actually equals to f prime x over fx. Yeah. Okay. So just the information for you, I have put in the formula that will be given in your exam as well. So you can realize that they only give you the what is that called, the basic one, which is natural log x give you 1 over x, and ex will give you ex. So the part where we talk about fx, right, meaning for example this one, you will need to memorize yourself for the exam. Okay, all right, so let's move on to the example. Okay, so example 3 number A. So same thing, y equals to natural log 2x. So dy dx. So this is like an easy fx as well. So differentiate your fx, so you get 2. Then after that over, then you write down your exact original value of your fx. So what do you get? 1 over x. Okay, so let's move on to B. Natural log 4x minus 3. So same thing, just differentiate, y equal to, so dy dx will be equals to, differentiate, you get 4. So 4x minus 3. Okay, so do not need to simplify further. Okay, C, y equals to natural log square root 5 minus x. Okay, so what you can try to do here, so same thing, you might need to change it into indices as well. So 5 minus 5 minus x to the power of 1 over 2. Okay, so it depends on you whether how you want to look at it. I mean, you want to treat this as composite, then after that you solve the composite, then you take it out. So the other easier way that you can do is, if you can recall, right, this is like the same thing if you have, let's say, log AB. So what you can try to do, so the 2 here, you can move it up, right? So they are the same thing. So that's why this thing, I can actually move it in front. So I just treat it as a constant multiple. So 5 minus x. Okay, then this will be easier formula. So 1 over 2. So what do I left? Negative 1 over 5 minus x. Okay, so I just combine them. Negative 1 over 2, 5 minus x. Okay, so if you want your answer to be better, then you can try to change around to make your x positive, that minus 5. Yeah, but that's all right. You can just leave your answer as that. Okay, so you can try the other one, which you try to use the what is that called, the composite also can. Okay, let's move on. Okay, E, so this is an easy one as well. So y equals to natural log 1 over x. So we can always change the 1 over x into indices. So it will become easier for us. Okay, so negative natural log x. So dy dx will actually equals to negative 1 over x. Okay, all right, so E. But please make sure that the negative one is belong to x only. Okay, so if you have something like this, then please don't do this because they means the different thing. So this one, the negative one, you cannot bring it in front. Yeah, okay. So E. Okay, E, so for this question, what we can try to do is let's try to simplify it first. So y equal to natural log, let me just copy first. So maybe we can try to change this already. Okay, 1 over 2. So you can realize that, I mean, you wouldn't choose to do like the binomial expansion here, right? So that's why we can use the idea for log a b actually equals to log a plus log b. So that's why y equals to natural log x squared plus natural log for 3 minus x squared 1 over 2. So same thing, we do not want to deal with the composite. So what we can try to do is the power, we can move it to the front. Okay, then now we can start our dy dx. So differentiate x squared give you 2x over x squared. So plus 1 over 2. So you differentiate this one, you get negative 2 over 3x, 3 minus 2x as well. Okay, so simplify it. So 2x over x squared, you get 2 over x. And then 2, you cancel out each other. So minus 1 over 3 minus 2x. All right, so let's go to the next one. Okay, so f natural log, so y equals to natural log 1 minus 2x over 1 plus 3x. Okay, so as you see this one, right, do you actually need to expand it? Yeah, so you do not need to do that. So same thing. So remember that when you actually solve for natural log, there are plenty of principle that you can try to simplify or expand it. So that's why instead of like actually expand it, what we can try to do is we move the 2 in front. So how about this part? So we are having like a u over v, which we actually can't do our differentiation as well. But you remember natural log a over b. So what we can try to do, it will become minus. Okay, so natural log 1 minus 2x and then minus natural log 1 plus 3x. Okay, so make sure that your 2, you must be expand it after that. Okay, so depends on you lah whether you want to, maybe we can just expand it now so you won't forget later. So minus 2 natural log 1 plus 3x. So now you can start to do differentiation. Okay, so 2, then what you have, negative 2 over 1 over 2x minus 2, then you have 3 over 1 plus 3x. Okay, simplify it, negative 4 over 1 over 2, 1 minus 2x, and then minus 6 over 1 plus 3x. Okay, so you can just leave your answer like this. Okay, move on to next one. Okay, so we'll end with the last question here, which you can see that this is not something that you can simplify by using the principle of log anymore. Yeah, because it's like multiply, and definitely this is like a u and this is like a v. So that's why we need to use our product rule again. Okay, so u will be equals to 2x to the power of 4, then v will be equals to natural log 5x. So du dx gives you 8x 3 dv dx gives you 5 over 5x, which is just 1 over x. Okay, so now you can continue by doing your differentiation. So dy dx will be equals to u dv dx minus v du dx. So u is 2x to the power of 4 dv dx 1 over x minus v, and also du dx. So make sure that you are putting your bracket correctly. Okay, now same thing, let us try to see, do you have something that you can actually simplify? So you get x squared as well, and here you have x squared, so 2, you can definitely take out 2x squared. Okay, then after that, this one you left with 1 only lah. Then after that, minus, so 4, 1, 2, sorry, yeah, correct. So ln 5x. Okay, all right, so that's it for today's lesson. So please try to go through all the exercise and yeah, try to do more practice, especially like on those questions that you need application from your P1 knowledge. Okay, that's it. Thank you.